Hello everybody, today we are going to work on lesson 21-1. We are going to start learning how to solve equations by factoring. So today we're going to focus on the kind of equations that are written in standard form that have x squared plus bx plus c, so they're not going to have any numbers in front of your x squared today. So homework for this lesson is going to be on pages 778 and 779. You're going to do 4 through 22 even. Here's what I want to just kind of set this lesson up with. We're going to do several lessons over the next few days on factoring. So I just kind of want to convince you that we like things that are in factored form, which is why we want to work so hard at learning how to factor. So I want to just kind of go back and remind you that in previous lessons, I'm just going to flip it back here. Remember how easy this lesson was when you guys did 20-3 on the zero product property? How simple it was to be like, oh my gosh, if y minus 7 times y minus 3 equals 0, then I can totally find the zeros and get the two answers, or y equals 7 and y equals 3, and like this was super easy. That's because these two sets of parentheses here that you see, that's called factored form. So what we're going to work on learning over the next few lessons is teaching you how to write your equations in factored form so that they will be this simple to solve. So we like factored form. We want to learn how to make anything we can look like factored form. So a few things that we're going to take a look at highlighting on this first page real quick. Just says right here that to find the factors for a trinomial that's in the form that we're going to see today, okay, you have to answer two questions. What numbers would have a product that equals c, and what numbers would have a sum that equal b? In other words, you're going to be asking yourself, what are two numbers that I could multiply together and get c? But if I added them, I get b. So it's going to become real clear to you why we made you do all those puzzles with the x's last week, because it is a skill to be able to find a pair of numbers that will multiply to one number but add to equal another number. So we're going to jump on down, okay, where there's a little bit of space, and I'm going to teach you something that we're going to use a lot over the next few lessons called the box method. Okay, we're going to put box method right here. Okay, and the box method literally means that you will draw a square box with 4 quadrants inside of it. Okay, and what you will do every time that you want to use the box is you will look at your problem and say, hey, this problem is x squared plus 5x plus 6 equals 0, and they want me to factor this. Every time, okay, you will put the x squared term, this a term, in the top left corner of the box. So you will put x squared in the top left corner. Okay, you will put your c in the bottom right. So that's 6 right there. We'll go in the bottom right. And what you will do is you will ask yourself, what two numbers can I come up with that will multiply to equal 6, but if I added them, they would equal 5. They multiply to equal c, they add to equal b. So you would say 3 times 2, right? So it doesn't matter which box you put the 3 in or the 2 in. Okay, but 3 times 2 is 6, and 3 plus 2 is 5. So you put those in there. They always get an x with them, so these two corners just always have an x. That's just part of it. And then what you do is you go through each column and through each row of the box, and you write down what factor they have in common. So in other words, what could they both be divided by? X squared and 2x both could be divided by x. X is their common factor. 3x and 6 could both be divided by 3. 3 is their common factor. I can't say x is a common factor because this one could be divided by x, but this one can't. And then whatever, like to know whether to put a plus or a minus sign in here, whatever this number is that is like your number that's touching the box, if this is a positive number, you will have a plus sign here. If this had been a negative number, you would put a minus sign here. And we'll see some like that in just a second. Then you go across this way. These two boxes could both be divided by x. X is their common factor. These two could both be divided by 2, and that's a positive 2, so you put a plus sign. So I'm going to put little parentheses around here, and here's the deal. This right here could be rewritten as x plus 3 times x plus 2 equals 0. And what we want to understand that you just did is that x squared plus 5x plus 6 and x plus 3 times x plus 2, they're the exact same thing. They're completely equivalent. It's just this was in standard form and this was in factored form. If you took this problem right now and I said, hey guys, FOIL this, if you did x times x squared plus 2x plus 3x plus 6, you would come right back to the equation you just had. They're the same thing, just in a different format, because now that you have this in factored form, hey, super easy to solve. What are the two answers? The two answers are x equals -3 and x equals -2, just like we learned in previous lessons. So, regardless of how easy you think things come to you today, I want you to force yourself to use the box, because when things become not so easy in the following lessons, you're going to be very excited that you know how to use the box method. So, let's jump down and let's do the box method for a few more problems. Okay, there is a difference between when it says factor and solve. See how factor doesn't even have an equal sign? It literally just wants you to split this up into the two parentheses that are the factors, and you don't have to solve it because it doesn't say what it equals. But when you get down here to where it does say that it equals 0 and they say solve it, that's when I need you to take it that extra step and actually solve for what are the two values for x. So let's do number 2. Okay, on number 2, let's get used to, if they say factor, you draw a box. Every time this first term x squared goes in the top left, the c term goes in the bottom right, and you ask yourself the question, what two numbers can I multiply to get c and add to get b? So if I were going to say, how do I get 4 and 4, I would say that it should be 2 times 2. So you make it 2x and 2x. They always get an x. They just do. Then on the outside of the box, you go through each row and column. You say, what could these two numbers in this column both be divided by? X. What could these both be divided by? 2. And since this is a positive, this is a positive. These could both be divided by x, divided by 2. Positive, positive. Your factors are x plus 2 times x plus 2. Moving on, keep it going. Number 3, they say factor it, you draw a box. The first term goes in the upper left, the c term goes in the lower right, and you say, what could I multiply to get 3? But it should add to equal -4. Okay, so I would say -1 times -3. They get x's, always. Okay? Alright, these have what in common? An x. Okay, right here, 1 and 3 can both be divided by 1. But see how that's a -1? That's how you know to put a minus. These can both be divided by x. These can both be divided by 3. It's a negative, you put a minus. So x minus 1 times x minus 3 are your factors. One more of those. Number 4, if it says factor, you draw a box. X squared in the top left, -10 is your c term. So you need two numbers that will multiply to -10, but they should add to 3. So you want to go with a -2 and a +5. Go through the common factors. These can both be divided by x. These can both be divided by 2. That's a negative, you put a minus. These can both be divided by x. 5 and 10 can both be divided by 5. That's a positive, this is a plus. Your factors are x minus 2 times x plus 5. Okay, now let's move to the ones that say solve. Okay, example 5. You still have to factor it, So I'm still going to draw my box. X squared goes in the top left. 35 goes in the lower right. And we say, what could we multiply to get 35, but it should add up to 12? And that's going to be 7 times 5. These share an x. 7 and 35 can both be divided by 7. That's a positive, plus. These can both be divided by x. These can both be divided by 5. That's a positive, plus. So here's the difference. Your factors are x plus 7 times x plus 5. But because it says equals 0 and they say solve it, they want to know what would your x values be that would make this equal 0. So that's where you need to finish it out and find the zeros. To make x plus 7 equal 0, you would need x equals negative 7. And to make x plus 5 equals 0, you would need x equals negative 5. So when they say solve it, make sure you finalize the answers and solve. Okay, let's do a couple more of those. Number 6. You still have to factor it, which means you need the box. X squared, top left. 18, bottom right. Numbers that will multiply to 18, but add up to negative 9. It's going to be a negative 3 and a negative 6. Okay, what do they have in common? These share a factor of x. 3 and 18 can both be divided by 3. This is a negative, put a minus. These share a factor of x. Okay, here's the first one where these share a couple, right? 6 and 18 can both be divided by a few things. They can both be divided by 2. They can both be divided by 3. They can both be divided by 6. You want greatest common factor. So we want to go with the idea they can both be divided by 6. And that 6 is a negative, so you put a minus. So your factors are x minus 3 times x minus 6 equals 0. You got to go ahead and solve. So your answers would be x equals 3 and x equals 6. Okay, and then number 7's a good one just to finish up these front examples on. You want to draw the box to factor it, and you have x squared and negative 20. Okay, so don't forget that if there's not a number in front of your x, imagine there's a 1 there. So you're asking yourself, what could you multiply to get negative 20, but add to get negative 1? It's going to be a negative 5 and a positive 4. So these share an x. These can both be divided by 5. Negative, so minus. These share an x. These can both be divided by 2, but go higher, go greatest common factor. They can both be divided by 4. It's a positive, put plus. So you're going to have x minus 5 times x plus 4 equals 0. Don't forget to finish and solve. X equals 5. X equals negative 4. All right, so there's the basics of factoring. Let's take it a step further because so far all the ones you asked to solve already equaled 0. But what if they don't? You need to add back here that if the equation does not already equal 0, you have to rewrite it to equal 0 before trying to factor it. Have to. So let's try that on a couple. Okay, see these examples right here? X squared plus 15x equals negative 54. Okay, that does not already equal 0. You have to make that happen before you try to factor it. So all that takes is simply moving the negative 54 over to this side and making it a positive 54. So you're going to have x squared plus 15x plus 54 equals 0. Okay. All right, now you're going to factor that. So you're going to draw the box. I'm going to leave a line of space so that I have room to write my factors on top. And now you fill it in. X squared in the top left, 54 in the bottom right. And you say, what could I multiply to get 54 that would add to get 15? It's going to be 9 times 6. So common factors. These have an x. 9 and 54 can both be divided by 9. It's a positive. Go across. Top row can both be divided by x. 6 and 54. Greatest common factor is 6. it's a positive, so put a plus sign. So you guys have factors of x plus 9 times x plus 6 equals 0. Solve it. The two answers are x equals negative 9 and x equals negative 6. Okay? One more time on that just for good measure. Number 6 from page 777 says x squared minus x equals 56. We don't want it to equal 56. You need to make it equal 0 before you try to factor it with the box or it won't work. So you need to move that 56 over and make it a negative 56. So this should say x squared minus x minus 56 equals 0, and then you can do the box. So if it doesn't equal 0, make it equal 0. X squared goes in the top left, negative 56 goes in the bottom right, and you're looking for numbers that will multiply to negative 56, but they should add up to negative 1. So that's going to be negative 8 times 7. So common factors, these both share an x. 8 and 56 can be divided by several things, but 8 is the greatest common factor. It's a negative, put a minus. Going across, x, 7 and 56, 7. It's a positive 7, you do a plus 7. So your factors are x minus 8 times x plus 7 equals 0. Got it in factored form. Solve it. Solutions are x equals 8 and x equals negative 7. All right, we're on a roll now to word problems. So we are going to take a look at page 777 in the book. Here we go. Okay, page 777, we've got an architecture example right here. I'm going to zoom on in on it. Okay, it says, let's say we have a rectangular porch that has dimensions of x plus 12 and x plus 5 feet. If the area of the porch floor is 120 square feet, what are its length and width? Okay, so see how these are the length and width? X plus 12 and x plus 5. That is the length times width. Okay, but those aren't just solid measurements that I can be like, oh, I get how long that porch is. So if I know that area of a porch is length times width, here's my length times my width. It has to equal 120 square feet. So let's write this out as a problem here. Okay, we know that x plus 12 and x plus 5 are the length and width of the porch. So if I do length times width, that gets me the area, and they told me the area was 120 square feet. So hopefully you're starting to look at this and be like, oh, she said in the last problems you have to make it equal 0. Well, you do. Can't be 120. But there's a little bit of a problem because this is already factored, and then you need to move the 120 over. You can't just move the 120 over and put minus 120 after those parentheses. That's not going to work. We got to get the 120 merged in there with the numbers. So you have to do a little extra work here. What you're going to have to do first is you're going to have to FOIL this to get it out of factored form. Then pull the 120 over, then put it back in factored form. So you got a little effort to put in here. So let's FOIL it. Okay, first, x times x is x squared. Outer, x times 5 is 5x. Inner, 12 times x is 12x. Last, 12 times 5 is 60. Equals 120. Okay, combine your like terms there, right? The 5x and the 12x should be combined to make 17x. So we have x squared plus 17x. And then I'm going to go ahead and adjust this, okay? See the plus 60? I need to move the 120 over with it. So it would be 60 minus 120. So it's going to turn into negative 60. Now it equals 0. So that foiling had to be done in order for you to be able to move the 120 over. Now that it's foiled, we need to factor it back out. So now I'm going to draw the box. And in my box, I'm going to put x squared in the top left. I'm going to put negative 60 in the bottom right and ask myself, what can I multiply to get negative 60? But it has to add up to 17. It is going to be negative 3 times 20. So common factors, x, 3 and 60 can both be divided by 3, negative sign, minus. These can both be divided by x. 20 and 60 can both be divided by greatest factor would be 20. It's a positive, you put a plus. So I now know that x minus 3 times x plus 20 equals 0. Okay, so I need to solve. X could equal 3 or x could equal negative 20. Okay, guys, let's think for a second. If I'm talking about, okay, the porch here, it doesn't make any sense for any of my things to have negative lengths or widths on a porch. So let's cancel out, like the negative doesn't make any sense. So let's say x is 3. So we've done a great job. We have figured out that x is 3. But the question was, what are the length and the width of the porch? Go back to the beginning. See how your length and width were x plus 12 and x plus 5? Well, now all you've done is solve for x. So if you know the length and width are x plus 12 and x plus 5, I now need you to actually replace the x with a 3. So 3 plus 12 means we've got 15 feet, and 3 plus 5 means we have 8 feet. So 15 feet and 8 feet are the length and width of the porch. Those are the dimensions of the porch. Okay? All right, so that's actually it for notes. On page 779, number 19 is actually part of what would have been in your homework, and we're going to look at that just as an example to help you out with something that you guys are going to do in other problems. So we're going to do 779 number 19 real quick. Okay? So take a look at that one. Okay? On that problem, okay? It says a rectangular Persian carpet has an area of this much. So that's the area. And a length of x plus 5 feet. So see how they tell you the area and they tell you the length? What do they not tell you? The width. Okay, so here's what I want us to do first. Okay, they're talking about, okay, a Persian carpet. Okay, it's like a rug. Okay, so in other words, let's jot this down. Would you agree that to find the area of the rug, you do the length times the width, right? And they have told you that the area of that rug is x squared plus x minus 20. Okay, well, here's the deal. They also told you that the length of the rug is x plus 5. And it needs to come out to equal x squared plus x minus 20. Sorry for my messy x there. Your job is to figure out what would have to go here. So x plus 5 times what would make this happen? So what could you multiply to get negative 20, but add to get 1? Okay? So if you're going to multiply to get negative 20 and add to get 1, you guys could do the box and have x squared and negative 20 here. Okay? But if you're thinking about what you could multiply, wouldn't 5 times negative 4 work? And look, that would be x and 5, which you already had. And this one would be x and 4, but it would be a negative. There you go. Your missing width is right there. Okay, so now that you have gotten it to that point, okay, let's move on to the rest of the question and we'll come back. Okay, it says, then, okay, the Persian carpet is displayed on a wall. The wall has a width of x plus 2 feet and an area of this. Find the dimensions of the rug and the wall if x equals 20 feet. Okay, so let's go to the wall. Again, length times width equals the area of the wall, right? And they told you that the area of the wall is x squared plus 17x plus 30. Gave you that. They also told you the width of the wall was x plus 2. So that means you need to figure out what goes here. So some of you are getting real good at this now, where you could go ahead and come up with, without the box even, what would multiply to 30 but add to 17? Wouldn't it be 15 times 2? So this should be x plus 15. See? Okay, now, here was the final part of the question. Final part of the question is find the dimensions of the rug and the wall if x is 20 feet. Well, you've gotten it to the point now where you know that the length and the width are these factors. Well, they're telling you, what if it was 20? If they said x was 20, that would be 20 plus 5, which is 25 feet, and 20 minus 4, which is 16 feet. So the dimensions of the rug are 25 feet by 16 feet. The wall, if x is 20, you'd have 20 plus 15, which is 35 feet. And you would have 20 plus 2, which is 22 feet. So the dimensions of the wall are 35 feet by 22 feet, and you just solved it. So once again, homework is on pages 778 to 779, 4 through 22 even. Lots and lots of factoring, lots and lots of boxes. Pay attention to making sure it equals 0 before you try to draw the box. And we want to get amazing at factoring because we're going to use it lots and lots for the next few days. Good luck with lesson 21-1.